number 80 or 79. Okay, we're given an equation, so I'm going to write it up here just in case you don't have your book. All right, so this time I have a 2-to-1 to 1-to-1 ratio. All right, in number 79, I am, let's see, I want to know grams. This one is a little bit different. Okay, I'm trying to find grams of CO2, I believe. Okay, yep, that's right. Okay, and I'm given the volume and the molarity. Okay, so if I'm given two pieces of information about one of our compounds here, that's where I'm going to have to start. Okay, so I'm given that I have 54.55 milliliters of a 0.957 molarity solution. Okay, so if we look at our molarity equation, molarity equals moles over liters. Okay, we can take that volume. Okay, if we rearrange this equation, remember this is one of our most important reasons for using molarity here. Molarity times liters equals moles. So instead of, like the last problem, we went from grams to moles, right? Well, now we can still get to moles. We just have to multiply molarity times liters, or liters times molarity. Okay, so I'm going to use liters just because milliliters might confuse some of you. Okay, so I'm going to move my decimal over. Okay, so you move your decimal to the left 3 places when you move from milliliters to liters. Okay, and the molarity I'm given is 0.957 moles per liter. Okay, I'm just showing the units written out as moles per liter so you see how it cancels. Okay, this right here, all that is the molarity, right? It's just written out as moles per liter. Okay, so I take the volume times the molarity. Okay, so now I'm in moles. Okay. All right, so we've gone from liters to moles. Okay, the next step is from moles to moles of what we're trying to find. Okay, so how many moles do we have in our equation for KOH? We have 2. Okay, and then what are we trying to find? Yep, the CO2, and how many moles do we have of it? Just 1. Okay. All right, and the last thing it asks is for grams. So we're going to do the same thing that you did back in the first unit. We all know how to get from moles to grams, right? Okay, so in 1 mole of CO2, there, if you add up the molar mass, you get 44.01. We've added up that quite a bit too, so, okay. So moles cancel, and we get 1.15 grams of CO2. Okay, so we need a 1.15 grams of CO2 in order for us to react completely with the KOH with the 54.55 milliliters at 0.957 molarity. Okay, so this one was a little bit different in the sense we were asked for grams at the end, okay, instead of starting with grams in the beginning. Okay, so we just went from moles to grams. Number 80, I'll write it up here. We've got barium hydroxide whoops, plus oh, all right, in this problem, there's no grams at all, and we're not asked to find grams. Okay, so this one we're going to have to use our molarities. Okay, so we're going to go from liters to moles by using molarity. We're going to go to moles by using our balanced equation here. And then we're going to go, last we're asked for liters here, or milliliters. And we're going to do that by using molarity. Okay, so instead of grams to moles, we're using liters and molarity to get to moles. All right, I'm going to do this one in milliliters just to show you the difference. There's not really much of a difference, but okay, you're given 45.55 milliliters. And the molarity is 0.0515. Okay, so if you're in milliliters, the only difference is you're in millimoles. And this is all so this right here, remember molarity can also equal millimoles per milliliters. I didn't move a decimal, I didn't do anything, I just left it how it was. Okay, so we have 45 milliliters. Okay, so this is often, and this is easier for me just because I can start with what I'm given, I don't have to move a decimal. Okay, and so I just start with the milliliters. Okay, so I go multiply times the molarity, so all this is right here is molarity. That was given to us. Okay. All right, now I couldn't fit in there barium hydroxide, but of course we're still barium hydroxide up there on the top. All right, our next step is the mole to mole ratio. So we have 1 mole or millimole. And we're looking for the volume of nitric acid. So that's our second reagent there, and we have 2. Okay. All right, the last step is we want to find the volume. Okay, so what am I going to plug in here in the last step? The molarity, exactly. So we have 0.558 millimoles. Okay, so I got that number from the problem. And 1 milliliter, 3. So the only difference is my answer is in milliliters, which is nice here because this is a small number. Okay, so if you did this in liters, then you would have gotten 0.00841 liters, which is the same thing as 8.41 milliliters. Okay, but if you were to tell me to measure out 0.00841 liters, then I'm automatically going to convert that to milliliters because it's a small number, so I'm going to get out my little graduated cylinder or little burette. Okay, so it's easier to look at in milliliters when you're on a smaller scale. All right, any questions? Are y'all getting these? I can't really tell. Are y'all getting the answers right from what you have? Okay, awesome. Then we'll just Well, I'll write through this one then, the next one. Okay. 81, our equation is this. Okay, for 81, we start with moles. Okay, so what does that mean? Is that going to add a step, take away a step that we've been doing, or how many steps are we going to have here? Okay, somebody said 2. Okay, yeah, we're going to have 2. All right, instead of being given grams, it's like it's already done for us. We've been given moles, so all we have to do is take that moles, so that 0.960 moles of calcium hydroxide. And the first thing we do is we compare our mole to mole ratio. So we have a 1 mole calcium hydroxide for every 2 moles of hydrobromic acid, which is what we're looking for. And then we want to find volume, so we know we're going to have to use the molarity. So we plug in our molarity, which is moles per liter. We just have it flipped over here in the denominator. And we get 3.44 liters of hydrobromic acid. Questions? All right, we're going to move to chapter 14, talking more about solutions. Okay, so we're just going to build on what we've already learned. Okay, I'm going to pass these around. You may already have one. I printed out 30 this time. Hopefully that'll be enough. But you can follow along the same problems I have up here. I have on that sheet, so you can write them down in just kind of an orderly fashion there. Okay, so as of right now, we've looked at 2 ways to express concentration. So what I mean is by you knowing, what the molarity is, okay, of a solution tells us what the concentration is. So the higher that number, the more concentrated the solution will be. Okay, so we've looked at molarity. We've also looked at one other one. Does anybody remember what that was? You had a couple problems on your exam over it. Okay. No, that's your dilution, so it's not the same. I remember. Percent. Okay. Percent by mass. Okay. Where you take the mass of your solute over the total mass of the solution times 100. Okay, so that one was, I think maybe just one problem. I don't remember on the last exam. Okay, but we're going to revisit that again today. And then we're going to add a couple more ways that we express concentration. Okay, these are, most commonly we use molarity. Okay, the lab upstairs, just in a lot of your older lab manuals and things, use normality. Okay, so Miss Janice, that's what she grew up learning, was normality. Okay, so that was a little confusing to y'all on Monday, but a lot of times normality and molarity are the same. Okay, one day we'll talk about the difference, but we're not going to do that today. But most commonly, the present day, we use molarity is the most common. Okay, and we use percent by mass. That's probably, maybe it's up there. Okay, and then we're going to talk about 2 more ways, and then we're going to do one long problem. So the last problem on that sheet there is going to put everything together. So you're going to have a problem just like that on your exam. Not maybe exactly, but very close. Okay, so you're going to put it all together, and we're going to have to use density. We're going to have to think about things that we've used, previously as well. Okay, so today we're not going to get really into the process. Okay, dissolution is just the process of making a solution, soluble. So the idea of like dissolves like that we've talked about in labs. Everybody remember us talking about that? Okay, so polar dissolves polar, non-polar, non-polar. But we're going to talk about that next week. Today we're just going to work more problems. I know you're excited about that. And just talk about number 1 right here, the ways to express concentration. Okay, so we're going to review what we just said here. Percent by mass is one way, so you can give a percentage of the solute in the solution. So if I say the percent by mass, okay, is 20% NaOH, that tells me that of that solution, 20% of it is the NaOH concentration. Okay, so 20 of the whole solution. Okay, we write that usually abbreviated as percent W over W, even though weight and mass aren't really the same thing, but that's just, they use them interchangeable, so that W kind of stands for weight. Okay, the main thing here is to notice, if it's mass, what's our unit? Grams, exactly. So it's always going to be grams there. So grams of the solute, that's what's present in the smallest amount. Okay, and it's grams of the total, if you want to write that in, you can, solution. Okay. Now, this seems pretty simple, but I want to just be sure everybody gets this. Okay. If we have a container, so we have a beaker here, well, whatever. It'll look like a beaker. Okay. So here we've got, we'll just say this is some salt here. So we would label this, right, as our solute. Okay? It doesn't have to be a solid. I'm just showing it here, so we'll learn that next week. You know, we can have 2 solutions and one be our solute, so it doesn't have to be a solid. Okay, but if we have some salt, which you've made a salt solution in lab, okay, so here's our solute. Okay, and then if I fill it up with some water, okay, and of course this would mix up and we would dissolve it. Okay, what do we call the water? What's it? Is it our solution or is it our solvent? Solvent. Okay, this is commonly missed. I don't know why on the exam. Okay, the solute is what we're dissolving in the smallest amount. The solvent is what does the dissolving. I can't talk. Okay, this whole thing here, well, not necessarily where it's not any water at. The water plus the solute, the solvent plus solvent equals a solution. Solvent and solution are not the same. Okay? Now we could have more solutes. You can have 2, 3, 4. I mean, you can have lots of things that you dissolve. Okay? But your solute's what's being dissolved. The solvent dissolves the solute, and together as a whole, we call it a solution. Okay? Bless you. Okay, so actually, look at your number, before we move on, look at your number 3. Okay, because this one's actually not in the PowerPoint, I don't think it is. Okay, so we want to find the weight percent. You may want to write out beside that percent by mass. Of NaOH in 30-gram solution containing 6 grams of NaOH in water. Okay, so if we take part, okay, so what is our solute? Anybody? NaOH, okay, and it gave you that you have 6 grams. Okay, so is that for our percentage here, that's our part, right, over whole. Okay. So you would have 6 grams as your mass of solute, right? That's what our definition here says. Okay. It also says that we have that over mass of solution. Okay. So what's going to go in the bottom? 30. Everybody agree with that? Why not 36? Yes. Okay, that's where students will get messed up. If it told you you had 30 grams of solvent, then you would have to add the 2 together, okay? Because the 2 together make the solution, right? But here it tells you the mass of the solution. So it's telling you this number here. So you don't have to add anything to it. Okay, so you would take 6 divided by 30 times 100, and you get 20.0%. That's the answer there for that one. 20.0% of sodium hydroxide, so NaOH. Okay, does everybody get the difference there? Okay, if you look back when we did this, went over this in last unit, so I would advise you to go back and look at those problems too. That problem was different. We were given the mass of the solvent and the solute, so you had to add them together in this part here to get the total mass of the solution. Okay. Okay. Hopefully by now everybody knows our number 2 here, molarity. Okay, it takes into account the entire solution. So in detailed definition here, we've just been saying moles over liters, but it's moles of the solute over liters of the solution. So the solution is the total, right? Right. All right, so here we're going to introduce some more units, some concentration units. So these two we've already covered. And the third one we're going to look at is very similar to molarity, but it's called molality. Okay, so you got to be careful when you're reading these. I try to make it obvious. Okay, molality is given as it's actually italicized, but a lowercase m. Okay, remember our capital M is our molarity, right? Okay, I kind of think of it as molarity's the more common, so it's gets the capital letter. It has authority, I guess. Okay, molality also is used though. Okay, it comes in handy when you have maybe a solvent that comes, especially if it comes through mail or whatever, you order it from a chemical company, especially our big drums. A lot of times they'll just give the mass of that huge drum or the solution inside, okay, or the solvent. And so it's kilograms here instead of liters. Okay, so the difference in molality, okay, is this here, the denominator. Okay, so it's still moles of the solute, just like molarity, right, is moles of solute, over kilograms of solvent. Okay, keep in mind it's kilograms, so it's 1,000 times a gram. Okay, so we're going to have to, if we're given grams, we have to convert to kilograms, right, to be able to plug it in to here. Okay, and notice it's kilograms of just the solvent, not the total solution. Okay, so whatever your solvent is. Okay, a lot of times molarity and molality are nearly equal. They're close, okay, but not always, so we use both. All right, so the best way to do this is practice. This is the first one, I believe. Yep, number 1 on your sheet. Okay. If you see water, I'm not going to try to trick you with that. Water, it can be a solute, but not commonly. So if you have water in the problem, it's going to be your solvent. Okay, so I would remember that. And it means if you have a problem that says it's an aqueous solution, aqueous means what? In water, yeah. So you don't have to always be told water is the solvent, okay, or in water. It can just say aqueous, and that's what it means. It means it's in water. Okay, so let's write out our new formula. Okay, so that's a lowercase m there. Molality is moles of solute over kilograms of solvent. Okay. Right. Are moles and grams the same thing? No. Okay. Some of you accidentally on molarity tried to plug grams in instead of moles. Okay. If you're given grams, we know we can easily convert to moles, right? Okay. So that's the first thing we're going to do, and we'll actually keep using this molar mass for the other problems. So you may want to. It'll be in front of you so you can see it. Okay, so we're going to take our 108 grams of methanol. Okay. If we add up the molar mass, we have a carbon that's 12, 4 hydrogens that are 1.01 each, and and then an oxygen that's 16, so we get about 32.0 grams per mole. We have 3.38 moles of methanol. Okay, so we found our moles. Okay. We have to put in kilograms. Okay, so can we plug in 128 as is? No, because we're given grams. Okay, so which way do I move my decimal? To the left or to the right? This is a common little mistake as well. You end up getting a really big number. Okay, you got to move it to the left, right? Kilogram is going to be smaller because it's a bigger quantity than a gram. So you're going to move it to the left 3 places. So you get 0.128 kilograms. Okay, so our final answer is not just 26.4, it's 26.4 little m for molality of a methanol solution. Okay, now I want you to look at number 2. You're going to use the same formula, so I'll give you that hint there. Okay, this time, just like we've done over and over this semester, we've been able to use an equation and rearrange it. Okay, so here we have 3 variables in molality equals moles over kilograms. Okay, if you're given 2 of them, you can always find the other one, right? You just have to rearrange and use algebra. Okay, so I want you to look at number 2 and see what you would do there. Notice you're given that 108 grams of methanol again, so you can use the same moles. We just came up with the moles, so you don't have to recalculate that. Okay, what answer are y'all coming up with? Anybody? Or 91.4 grams? Okay, very good. Let's show that. Okay, so we've got our original molality equals moles over kilograms. We want to know grams of water, which we know we can easily go from kilograms to grams, right? So we can rearrange this to solve for kilograms. Okay. You can write it out and then rearrange. Doesn't matter. I'm just rearranging from the beginning, so I can go ahead and plug in. Okay. My moles are just like the previous problem, so I didn't have to recalculate there. Okay. And the molality is 37 because that's given to us right here. So I get 0.0914 kilograms. Okay. To get grams, I multiply times 1,000, which means I move my decimal over 3 places. So that gives me 91.4 grams of water. Okay. This is very useful as well. If you know what the concentration that you want to make a solution, so a lot of times in procedures, okay, for you guys, we don't do anything that detailed yet. We make the solutions for you most of the time. But if I needed to make a 37 molality solution, that's what my procedure called for. Okay, and I know that I have 108 grams of methanol, so that's what I've got in my storage cabinet or in my chemical cabinet. So I need to know how much water do I need to use. It's very, very useful. So then I just, measure it out. I can do the mass there. I could also use the density and get my milliliters if I wanted to. Okay. The last one we're going to look at is called mole fraction. Okay, and the name is exactly what it is. It's a fraction of moles. So the only thing you're going to be plugging in are the moles of your solute over the moles of all the components. So if you have one solute and one solvent, then you would divide by the moles, the total moles of your two components. Okay? This is actually dimensionless, so you're not going to have a unit at the end. So your unit is not moles, okay, because those all cancel. Okay, so there's no unit here. This is used much later if any of you go into any kind of analytical chemistry, or even really have to even be in chemistry, but this is used a lot for looking at pressures. Okay, they use the mole fractions, the different moles, and we'll actually kind of see this later in the semester again. But they take these mole fractions and it helps them to come up with pressures and things of gases. So we don't use this a lot in the lab because we're only doing gas law labs at the very end of the semester. So we're going to use solutions for the most part. So, but anyways, we're going to learn how to do it nonetheless. So what you do is you take, if you're looking for the mole fraction of, let's say, A. So A could be anything. So that could be your solute. So let's say it's sodium hydroxide. Okay? You would take the moles of it. So if you're given grams, you'd convert to moles. Or if you're given moles, then you just simply use it. Okay? And then you divide it by the total moles of everything in the solution. Okay? So you would divide it again by itself because it has, that's one component. Okay? So the NaOH is just an example here. Plus, let's say we have it in water. We need to know the moles of the water. Okay? If we had another component in there, so if we had, some HCl in there, okay, then we would add that as well. Okay, so but most times I would just use the two-component solution. Okay, if you want to look for the mole fraction of B, so let's say B was the water, then you would put the moles of the water. So whatever you're looking for, you need to put that on top in the numerator. So you'd have the moles of the water divided by the total moles in the solution, which that should be the same for A and B. Okay, if you have two components and you add up, if you find the mole fraction for A and B, they should always equal 1. Okay? So if you had A, B, and C, so you had another component, they should all add up to equal 1. Because that's a way to check your answer. If they don't add up to equal 1, then you did something wrong. Okay? So if we look at so we already did number 3, so that was kind of out of order there, but look at number 4. Okay, we want to find the mole fraction of methanol and water using the information from problem 1. So this just makes us not have to go back and calculate moles again because we already did that. Okay, so if we're looking for the mole fraction, so it's given this symbol X, okay, for the mole fraction, and we're looking for methanol, so we're going to write that out here. All right. From problem 1, how many moles of methanol do we have? Okay, 3.38, right? Okay. Mole fraction says then we divide by the total moles. Okay, so we're going to have to add at the bottom of 3.38 again, right, in the bottom, right, because we have to do total moles. So we have 3.38 moles of methanol. Okay, so we got that from here. That's one component. Okay. All right, and what's our other component of the solution? It's water, right? Okay, so we have 128 grams of water, but we need moles, right? You can't plug in 128 here. We have to go from grams to moles. So we take our 128 grams of water. Oxygen 16, hydrogens are each 1, so you get about 18 point, I think I just used 18.0 or 18.02, whatever you want to use there. Okay, and you get 1 mole up here. So we get 7.11 moles. So we have more moles of water, which makes sense, right? Because the solvent is usually present in the most amount. Okay, so we put 3.38 plus 7.11. Okay, so you'd add up 7.11 and 3.38 and divide that into 3.38, and you should get 0.322. So you get your mole fraction. That's all it is. Okay, we really don't even have to do the next part by taking the mole fraction of water. We're going to go ahead and do it anyways. But we know if they have to equal 1, then we could just take 1 minus 0.322, and that would give us the mole fraction of water. Okay, but we're still going to show it. So if we go here, okay, so it was 7.11 divided by the 3.38 plus 7.11 gives us 0.678. Notice I have no units here. Okay, and if you added both of those up, you get about 1. Okay? I think you would get exactly 1 there. Okay, questions on those. We have 4 different ways to express concentration: molarity, molality, and percent by mass, and mole fraction. Okay. All right, so I want you to look at number 5. This one you might need more space. You can flip to the back of the sheet here. Okay, this is going to put all those together. So it's asking you to find molarity, molality, mole fraction, and weight percent. Okay, usually it's easier to start with molarity. Is what I try to put them in the order that's okay, and they're all going to kind of build on each other. Okay, this keeps you from having a separate problem for each where you keep having to calculate moles and doing the same thing over and over. Okay, so if you look here, you're given 25 grams of sucrose dissolved in 525 milliliters of ethanol. Okay, so which ones are solute? Right? Okay, sucrose, exactly. Okay, the ethanol is our solvent here. Okay, so the first part, molarity, is pretty straightforward. You're first going to have to convert the 25 grams to moles, right? And then you're going to be using that moles for the rest. You don't have to, do it again. You can find the moles, and then you're just going to plug in for molarity. So moles over liters, you're given you're given 525 milliliters. You can convert that to liters. Okay, number 2, you're going to probably run into a little issue. So I'm going to go ahead and give you a hint, okay, of what to do. Okay, But notice in parenthesis at the end, it tells you the density of ethanol. Okay. In number 2, you're going to have to use density. So we've come across this quite a few times in problems even the other day. Okay, so you're going to need to find grams, and the only way to do that from a volume is to use density. Okay, so that'll give you a hint there. And then after that, it's pretty straightforward. Okay, so go ahead and work on these a few minutes. I'll walk around and see if you need help, and then we'll go over it. Okay, if you finish this one, 26 and 32 in your textbook are also great problems to work. Okay, so we'll also be doing those. So if you finish this quickly, you can start 26 and 32. Check your, so that's your molarity, so be sure you put your units there. So you got 0.139, it's a little bit different. Maybe mine's off. I'll check mine, but yeah, that looks good. Okay, yeah, and then you're going to take that, so if you multiply exactly, your milliliters will cancel, and you'll multiply times that, and that'll give you grams, and then you can convert that to kilograms. Mm-hmm. If you're stuck, raise your hand so I can at least get you started. Y'all going okay over here? Okay, what did everybody get for your molar mass of sucrose? Just to be sure we're on the right track. Okay, 342.34. So the first thing you have to do is find the molar mass and then convert from grams to moles. No, you move it to the left. Yeah, a liter is a larger quantity, 525. Yes, it's a little confusing because it's supposed to be like total liters of solution, but it's all in. Yes, it's because how you make it, when you add the 25, then you add the 525, it's going to still be 525. It's how you make them. I may demonstrate that in class because it's a little confusing. But yeah, you just use that 0.525 liters. Right, of your solvent. Okay, you're going to take your milliliters and you got to use density. Okay, if you multiply those two, it's going to give you your grams, which then you convert to kilograms. And then you're going to use your same moles, because it's just moles over kilograms. Or is that the one you have left to do? That was weight percent. Okay, so the mole fraction. Yeah, that's the only one. But the other ones look good. Mm-hmm. Yep, and then you just divide by 0.525 liters. Yes, that was telling me back there. It's a little confusing because I'm going to try to demonstrate this one day in class, but when you take the 25 and then you just add the 525, it's how you make it that it's still going to be 525. Yeah, so don't get confused on that. So yeah, sometimes it'll tell you the total, volume of the solution. But when you put the 25 in, then they just fill it up to 525. So it's considered to still be 525 because it dissolves. So, but I'll try to show it in class. But even when I show it, students are like, I don't get how I did that. But yeah, that same number is what you use for it.
Since it's milliliters, should I put that in milligrams first?
Okay, I think you're trying to do, you don't have to actually come up with that. So if you take your 525 milliliters, you multiply times the density, which is 785 grams per milliliter, then you're going to get your grams. And then you can convert to kilograms for the molality. Mm-hmm. milliliters to grams. Use your density. Density is grams per milliliter. Okay, I'll take a couple more minutes and then we'll go over it. See what we got. All right, first things, convert sucrose to moles. So you should have gotten 0.0730. Molarity is moles per liter, so you're given the 0.525 liters. We've removed the decimal back or left 3 places to go to liters. So you get 0.134 molarity of a sucrose solution. Okay. Molality is equal to moles as well of your solute, so we can go ahead and put that there, over kilograms. Okay. So if you run into a problem here where you're given the kilograms or you're given the solvent is ethanol, right? Okay, but we're given the volume. Okay, so our units are not in mass. Okay, the neat thing about density is its units has mass and volume. Okay, so we could use density to find grams. So if we take our 525 milliliters, we multiply it times the density, which is grams per milliliter, right? That's the units of density. Milliliters cancel, and we're left with 412 grams, which is equal to 0.412 kilograms. So we should get about 0.177 molality sucrose solution. And I meant to check that first one. Hang on one second. Yeah, that should be a 9 right there. I don't know why. It's at 0.139. Okay, any questions on this? How many of you got these two? Anybody? Awesome. All right, next one we're going to do is the mole fraction. So we take, it asks only for the mole fraction. It asks for all of this for sucrose. So we don't have to find, ethanol here. We're just looking for the mole fraction of our sucrose. Okay. So we already found that we have this many moles. Mole fraction is the moles of what your mole fractions, what you're looking for, goes on the top, the moles, and that divided by the total moles. Okay. Okay, the other component of our solution is what? We have sucrose and ethanol. Okay, and so what do you think I should go back up to that I've already found to be able to get to moles of ethanol? Yeah, go back to this grams. So you don't want to go to kilograms. Just go back to that 412. Okay, and so if I add up the molar mass of ethanol, I believe it's, what, about 46.08 about in 1 mole. So we get about 8.94 moles. So the fraction of this solution, okay, that is sucrose, is only 0.00810. A very small fraction is actually sucrose, so most of it is ethanol. All right, do I have units here? Nope, everything cancels. All right, last is our weight percent. Try to erase here. That doesn't work. That doesn't work either. Okay. Okay, so this was B. I just did it all on the same page there. Okay, weight percent, or percent by mass. Okay, we know we have to be in what units for this? In grams. All right, so how many grams of our solute do we have? 25.0. That was given to us in the problem. Okay. What about the total mass of the solution? Okay. Can we use just the 412 here? No. Okay, because the 412 is of the solvent, right? So we have to add them together. So we have to take 25.0 plus the 412 times 100, and we get 5.72% sugar, basically, solution. All right, any questions? Anybody get them all right? Anybody? A couple people? Okay. Like I said, there'll be one very similar, one or two, where you have to go through and find, all 4 of the ways to express concentration that we're going to cover. Okay, number 26 and 32, there's 3 or 4 parts to each of those. So it's the same idea. You're finding molality, molarity. Okay, just read these problems carefully. On Monday, I probably will even check to see if you've done these. This is where we're going to start on Monday. And there's some little differences. Okay, so you have to read the problems really careful. One of them is it'll tell you in aqueous solution, and we've already discussed that earlier, but students will come up and ask me, well, what's the solvent? Okay, and so if it says aqueous, you know the solvent is water. Okay, so it's understood that you know that. Most everything else is pretty similar to what we just did, so please work those, bring questions, and we will start with those on Monday. Have a good weekend. Have a good weekend. Bye, you too.